Okay, so we have a question here. The following represents the sales for a company in the year 2025. We have the sales here, right? They've been jumbled up for us. So usually with ungrouped data, what they like to do is they'll bring the numbers jumbled up for you. Okay, they'll be jumbled up. So first things first, before you even start solving for anything, make sure you arrange the numbers. Okay. Yes. So the numbers have been jumbled up. These represent the cells. Okay. So we have to find this information: the mean, median, mode, standard deviation, the range, upper and lower quartile, interquartile range, and the 40th percentile and the 60th percentile. Okay. So first things first, we just need to rearrange the numbers in chronological order. So we have 1, 2, 16, 19, 19, 21. All right, we've arranged the numbers. So first things first, we need to find the mean. Okay, so the formula for the mean is usually represented as x bar. Okay, the mean is, you can think of it as a number that represents the data set, or it's the average, which represents the general or the expected performance. All right. Yes. But I would advise the way you need what you need to remember for the mean is just that it's a number that represents a single number that represents the data set. I'll need you to remember that. Okay. Then the average, it being the average, yes, you can also know that's the average or the expected or general performance. But this definition where it says it's the number, the single number that represents a data set. Then there you'll be talking like a true statistician. Okay. So the formula for the mean, well, I believe we all remember it. We have to add all these numbers and divide them by the number of data values. Okay, so let's get our calculators. 1 plus 2 plus 16 plus 19 plus 19 plus 19 plus 21. What do we get? 78. Okay. Then we have, let's see, how many data values? 1, 2, 3, 4, 5, 6. So 78 divided by 6. 30. Yes. This is the average sales. Okay. As I said, the mean can be the average or it's the single number that represents the data set. So when I mean single number which represents the data set, if you can replace all these numbers with just 13, 13, 13, 13, 13, 13, 13, 13, 13. Okay. You can just replace all these numbers with this number here, 13. Any questions before we now move to the median, which is the number in the middle basically. 50% of the values fall below it, 50% of the values are above it. Okay, so since we have got a small group of numbers to get the median, okay, let's see here. Now, do we all remember that formula which I was using last time? Here, you don't really need to use it, but I just want to know so that I don't need to illustrate it again. The formula for the percentile. So since here the number of data values is small, okay, so you just cross out like this here, cross out like this here. All right, then our median is between these two numbers here. Okay, our median is between these two numbers. Okay, so 16 plus 9 divided by 2. Oh, that's in. Okay, you have solved everything. 17.5. 17.5. So that is our median here. Okay, 17.5. So 50% of the cells are below 17,500. Yes, is that a question? Yes, so 50% of the cells are below 17,500. 50% of the cells are above 17,500. Okay, and then if, as I said, if you had a lot of numbers, okay, where is that formula here? You can use this one here to find the median. The median is the 50th percentile, okay? So you can use this formula to find the, the median. Or you can also use this one, n plus 1 divided by 2, okay? Okay, we now go to the mode. So the mode, as we said, is the number that represents the number that is most common. And in this case, it's 19. So our mode is 19. All right. Yes. Now we come to the standard deviation. So colleagues, please pay attention so that this doesn't give you problems anymore. Okay, remember standard deviation is how far the data points are from the mean. Okay, if you get a low standard deviation like this one, you can see the data points are near the mean. All right, they are near the mean. But if you get a high standard deviation, means the data points are far from the mean. Okay, so in business terms, this can represent risk or fluctuations. Okay, risk or fluctuations. So for the standard deviation, we'll use, there are two formulae which we can use, but this is the most consumer friendly one. Okay, this one is the most consumer friendly one. So I'll use Excel for this. Okay, so you've got your values, your X values. Then you have your mean, X bar. Then each value, you subtract it from the mean. And then, so when you subtract a value from the mean, it's called a deviation, okay? So here we are subtracting each value from the mean. We just call a deviation. Then you square each deviation. Okay. So our data values, we had 1, 2, 16, 19, 19, and 21. 1, 2, 3, 4, 5, 6. Our mean we said was what was the mean? 13. Okay. So here you just put 13. Okay. 13, 13. Okay. Because I'm using Excel, that's why I'm putting 13. But on your workings, when you're solving in the exam, this column here where I put you don't need to put it. Okay. The reason why I've just put it is for you to remember, but you don't really need to put this column. Or even when you see books in books, you see they rarely put a column where there's the mean. So this is just for illustration purposes. So we calculate the deviations. 1 minus 13, negative 12. 2 minus 13, negative 11. 16 minus 13, 3. Okay. Each value you subtract from the mean. 19 minus 13, 6. 19 minus 13, 6. 21 minus 13, 8. Any questions, colleagues? Each value is subtracted from the mean to get your deviation. Then now we square each deviation, okay? Not square root, square, meaning you're multiplying each number by itself. Negative 12 times negative 12, 144. Negative 11 multiplied by negative 11, 121. 3 times 3, 9. 6 times 6, 36. 8 times 8, 64. Any questions, colleagues? This is the point where if standard deviation was giving you problems, this is where you can now ask any questions so far. And we're not even yet done. We're just in the process. But any questions? A negative one. And because you're squaring like this, put brackets, madam. Okay. Because mathematically, when you put it like this, you still get a negative number. So put brackets in so that it does that. Yes. Any other questions? All right. So, yes, yes, there are calculators which you can use, which can they'll make your life very simple. If you those who are in USAC, who want physical lessons, you can come. I'll show you what a calculator that does that. Various calculators, they are able to do this for you. You just put in the values and you press mean, standard deviation, and everything it calculates for you. But in the exam, you'll need to find out from your lecturer. Can we use statistical calculators, or we need to do it manually? So, madam, yes, there are some calculators which help you with that. Okay, they remove the workload because the thing about it is um, these questions take time. That's the problem. Okay, they take time. So you find you want a calculator to, you know, make things move fast. Okay. So even as I give a practice question, just try it on Excel. Okay, just try it on Excel. Excel, you won't it won't take long. Okay, so yes. Then these squared values, we need to get the total. Okay, 410. That is the total. Now we can now calculate first the variance, which is the standard deviation squared. Then the square root of the variance is the standard deviation. So we're going to use this formula here. So let me put it here. So colleagues, this top part in the numerator, we've already done it through the table, okay? The top part, this E just means you're summing up. Xi just means each data value. X bar means the mean, okay? So this numerator, we've already done it. The numerator was 410. So you're going to say 410 divided by n, which is the number of the data values, 6 minus 1. So 410 divided by 5, what do we get? 92. 82? Okay, so that's the variance. Basically, the standard deviation squared. So now to get the standard deviation, you get the square root of the variance. So what is the square root of 82? Excuse me. 9 point. Okay, then you can just leave it as 9. 9.0, I believe the other numbers are. Okay, let's put, yes, yes, because if you just put it as nines, unless it was 81 here, so at least you. Any questions, colleagues, on the standard deviation? Because most of you say we need to review standard deviation. So any questions so far? James, Madam Betty, Madam Kalinda, Madam Charity, Madam Dumase, Mr. Mr. Kaungolo, Madam Rhoda. Okay. Yes. Education is about progress. We need to, so that once you start the official lessons, colleagues, you're the ones shining in class. No, some don't even know you answer. Okay. Mm, the range is just the highest value or the maximum minus the smallest value or the minimum. Okay. So you go to your data set. Our highest value was 21 here. Right? Our highest value was 21. Our lowest value is 20. 20. Oh, it's 1, sorry. The lowest value is 1, not 20. In our range, 21 minus 1, that is 20. Okay. It's just showing you how wide your data set is basic. We have now our upper quartile and our lower quartile. So let me use the percentile formula so that when we reach this part, we can be able to calculate, right? Usually, as I said, this data set is very small. So before I even use the percentile formula, we can just get these manually. We saw that our mean was 17.5. So the mean cuts the data into half. So the lower quartile, it's basically the median of the lower half. Okay, and the upper quartile, think of it as the median as of the upper half. So you just look at the lower half and say, what's the number in the middle? It is 2. If you look at your upper quartile, so here the number in the middle is 2. So this is our lower quartile, which is represented as Q1, which is just telling us 25% of the values are below 2 and 75% of the values are above 2. In our upper quartile, you look at the upper half of the data set. The number in the middle is 19. So that is Q3, which is just saying us 75% of the data values are below 19 and 25% of the data values are above 19. So Q3 equals 19. Now, if we used the percentile formula, okay, the percentile formula is this one, n plus 1 multiplied by p, which is the percentile, over 100. So our lower quartile is the 25th percentile, okay? Q1, which is our lower quartile, is the 25th percentile. So here in our formula, n is 6, so it's a 6 plus 1 multiplied by 25 divided by 100. So 6 plus 1, that is 7. 7 times 25, 175. Divided by 100, 1.75, which can be rounded off to the second position. Okay. Because there's no 1.75 position. And if you gave us a 1.5, we'll know that, okay, that's position which is after the first position. But 1.75, it will be hard to find that position. So you say it is the second position. Yes, colleagues? Second position, which is this 2 here. Okay. For these positions, either a point 0.5 or a whole number. If you get this, if you are doing this formula and you get 1.75, 1.85, 1.95, your number for the positions is either it has a point 0.5 or a whole number. Then the upper quartile is the 75th percentile. So in this formula here, where there's P, replace it with 75. So 6 plus 1. Uh-huh. Yes. The 25th percentile is the lower quartile, and the 75th percentile is the upper quartile. Yes, that is, yes, yes. And median is the 50th percentile. Median, 50th percentile. So 6 plus 1. Um, yeah, so the last video I did, I posted a video on quarters. I used the bigger data set. Wait, ask that question. Then ask the question again. Uh-huh. Mhm. Okay, the lower quarter, this one too, this Q2 is the median, which we've already calculated. We already found the median. That's why I just went from Q1 and Q3. Because as I said, Q1 is the lower quartile, 25th percentile. Q3 is the upper quartile, 75th percentile. So why we skipped this Q2 here, the median, the 50th percentile, because we already calculated it earlier on. 6 plus 1. That is 7. 7 times 75, what do we get? 525 divided by 100. 5 point, yes, 5.25 is. So we round off, okay? Because as I said, these numbers here, when you're calculating, it has to have a point 0.5, which represents in the middle between two numbers, or you round it down to the nearest whole number. So 5.25, if you round it down, it's there, like the fifth position. And here we can count 1, 2, 3, 4, 5, which is 19. Any questions? The interquartile range is just the upper quartile, Q3, minus the lower quartile. 1920. Oh, colleagues, I have to go for another class, but another class which is pending. Let me just, okay, okay. Let me just finish up this one. No? Then I have to switch to another class. I'm 20 minutes late. Upper quartile was what? 19. Lower quartile was 2. So the interquartile range is 17. For these percentiles, here where there's P represent, replace it with 40. Okay. The 50th percent, 60th percentile, where there's P, represent it with 60. Then that will give you the position. Okay, to give you the position of the number. So you have to come back here on this to find, okay, which number is on the 40th percentile, number is on the 60th percentile.